सर्वेभ्यः अद्य सद्रत्नमालायाः दशमं सत्रम् अन्तिमं च प्रार्थनया प्रारम्भं कुर्मः। वक्रतुण्डमहाकाय सूर्यकोटिसमप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा सरस्वती नमस्तुभ्यं वरदे कामरूपिणि विद्यारम्भं करिष्यामि सिद्धिर्भवतु मे सदा। अज्ञानतिमिरान्धस्य ज्ञानाञ्जनशलाकया चक्षुरुन्मीलितं येन तस्मै श्रीगुरवे नमः। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। असाध्यः साधकस्वामिन् असाध्यं तव किं वद रामदूतकृपासिन्धोः मत्कार्यं साधय प्रभु। ओके, अद्य किञ्चित् सद्रत्नमाला पुस्तक इतर विषयान् किञ्चित् जानीमः। So I've already completed the portions last week. So today, in the earlier classes, I mentioned that okay, there are some things which are there in the Vaidika Ganitam, Bharatitirtha Swamina Virachitam Asti. Tattu Bharati Ganite न गण्यन्ते जनाः, तस्य गण्यते जनैः, अतः किञ्चित् तत्र भेदः वर्तते। यतोहि so that is a more recent text and it is not a part of the Bharatiya Ganita Parampara, and it is written based on the algebra which is taught in schools, and so it's a recent text. But he has some techniques which are a little advanced than what is shown in Sadratnamala, so we'll talk about it. Okay, so Sadratnamalayam Vargamulakriya यद् वयं जानीमः यत् अत्र प्रथमं चिन्तयन्तु अत्र संख्या एषा अस्ति. So if this is a number, we start out with okay वर्गः अवर्गः वर्गः अवर्गः वर्गः इति भिन्न भेदं कृत्वा तथा कुर्मः. So first we subtract the square root of 2, and then so we start with in the varga sthana, we subtract the square root of 2. After that, it is a repetition of cycle of division, subtraction, division, subtraction. So this is what, there is also a question in the first homework where we say that it's a kshaya kriya. So we keep the division and the subtraction are kshaya kriya. So those are both are used alternatingly in the vargamula kriya. It's also used in the dhanamula kriya. So the root techniques will use both the division and subtraction as shown here. So the first division is done with twice the first number. The second division is done by twice the first and second number. And you get 3 here. After first division, you get the second number. After the second division, you get the third number. The first number is always a special number which you just get by finding what's the largest square of the vargasthana of the earliest vargasthana. Okay, so this is how we do the Sadratnamala Vargamula Kriya. This is the same thing which is mentioned by Aryabhatta, starting with Aryabhatta, the 4th century mathematician, till Sadratnamala, he is in the 18th century or early 19th century also, actually late 18th century actually. So all the mathematicians in the parampara follow this kind of a kriya. It might be a little bit different, where like in Lilavati he talks about a little bit a different method, but generally the method is this, where they take one digit they bring down, and then the division becomes bigger and bigger, the division by the number. So this is here, but in Bharatiya Ganita So this is the Bharatiya Ganita. So as I mentioned, there are two divisors. First with 2 and then with 46. First division with 4 and then division by 46. And here we what we do the division is the so okay, let's say the 46 is the divisor, 326 is the dividend. So we have 322 is 7 times, it goes 7 times. So that's why we put this 322 here, right? So division by 46 is the biggest divisor. So it's not the same. Division by 4 and division by 46 is what we saw. This you probably know if we had done the homework. So the 7 comes because of 322 is for 2 times 23 times 7. Okay. So this we know. Now, this Bharati Tirtha Swami Vedic Ganita, it's Vedic mathematics. So basically, a lot of people think Vedic mathematics is the only Indian contribution to mathematics, which is actually contrary to what generally Indian mathematics means. By just naming the book Vedic mathematics, the author actually really throws people off. So they think it's all from Vedic, from Vedas. So none of the techniques are from the Vedas. He says sutras are there in the Atharva Veda, and there's no base. Nobody could find any sutras, those statements in the Atharva Veda. And then in the introduction, he also talks about, Vedas means all knowledge, and he gives a very introduction. Probably I don't know whether he wrote the introduction or the people who came further after the publisher wrote the introduction, but they say Veda means all knowledge, and any knowledge is also it can be called a Veda. So, but Veda is a Sanya Shabda. So Vedaha itukte Rigyedu Sama Tarvana Ityeva. If you say Veda means anything which is knowledge is Veda. He then says with it comes from the Dhatu with Vedaha, and knowledge itself is Veda. So then everything becomes a dilution, and it's not very clear. So then Vaidika Ganitam here means is it from the Veda or Ganitam based on knowledge is a big debate which people have even now, but I'm not going to go into it. So Vaidika Ganitam, that whole Vedic mathematics does not mean that these are all from the Vedas. So that's what I wanted to mention here. And so basically it's a very recent book. Just by naming the book Vedic mathematics, people are confused that it is about from the Vedas, and it's the oldest mathematics. So on the contrary, it is actually the newest, the more recent mathematics. Okay. So in that book, what he does is the divisor is always 4. Earlier we saw it is 4, 46, and if the numbers are big, you keep on increasing the number. So if the number are big, it can be the next divisor will be 2 times 237, which is bigger divisor. But in Vaidika Ganita, he gives a technique where the divisor stays at the first divisor is always the same. So the divisor is always the same. So the divisor stays at 4. So here again he does one small technique where this 322 is 2 times 23 times 7, which we saw earlier. So he splits that step. Basically earlier we had only one step here. He's splitting the step into 2. So writing 23 as 20 plus 3. So then you will have 2 times 20 plus times 7 and 2 times 3 times 7, which is 280 plus 42, which is actually 322. So what happens is this 2 times 20 times 7 is 280. So here is 280 plus 42. So this particular step which we did in the, I don't know, this color is some darkish blue color. This is split into 2 steps here. So that's what he does. And again, after that, that step remains the same. So you see here, the step remains the same. So I'm going to go back to the class part where I did a comparison with NCERT and Bharatiya Ganitam. So this was the example I showed. So if you want to find the square root of a number 45, 96, 84, in NCERT textbooks right now, what is taught in schools, they take 2 digits at a time, and then the divisor is bigger. So 127 that's the first divisor, 1348 is the next divisor. So this is what 127 times 7 is 889. 1348 times 8 is 10784. And I mentioned that Bharatiya Ganitam, what they do is they take one digit at a time. So 9 comes down, 6 comes down, 8 comes down, 4 comes down, and the divisors are smaller. So instead of 127, the divisor is 12 here, and instead of 1348, the divisor is 134. And here there is only one division, no subtraction. The division is replaced by division and a subtraction. So that's how Bharatiya Ganitam splits this division into 2 steps, is what I told, right? So if you see this 127 here is the divisor, here is 12, and 7 subtraction by 7 square. So I earlier also mentioned that the same slide I had. So 127 times 7 here, 889, is split into 120 into 7 plus 7 square. So so it's 840 plus 49. Here is 840 plus 49. That is what is 889 here. So they are combining 2 steps into 1 step. Here also again 134 times 8. So 1340 plus 8 is I'm splitting it into 2. 1340 into 8 plus 8 square, which is 10720 plus 64 is what is shown here. This is what Bharatiya Ganitam does compared to NCERT. So NCERT method is the Western method. Right now, I think, I don't know about what is taught in schools in the Europe and the Americas, but this is the, if you go to go to the internet and search what is the square rooting technique, this is what will come up. So taking 2 numbers at a time. This is a standardized method. Now I think NCERT is just following the method which is there in the followed all over the world. Generally, I don't know what is followed all over the world, but I think NCERT is following what is followed all over the world. Okay, so this is the Bharatiya Ganitam. So Bharatiya Ganitam makes it simpler, is what I'm saying. But Kim Bhavati Brihad Haranam, Brihad Haranam, Lagu Haranam plus Vyavakalanam. So it makes a bigger division into a smaller division and a subtraction. Okay. So in Bharati Tirtha Swaminaha Vaidiga Ganite, Punaha Tatheva Kriyate. Brihad Haranam, Lagu Haranam plus Vyavakalanam. So here till this point, it is the same for both. For example, if you take this 459684, so 459684 is the number here. So this is the Bharatiya Ganitam format. So basically, he's doing 2 times 6 and 7 square. 2 times 6 division is not very difficult, but the next step here, 2 times 67. So this particular thing is 134 is a divisor. So 134 divisor is a little difficult. So but here in Bharati Tirtha, what he does, Bharati Tirtha Swamiji, what he does is, so he still keeps 2 times 6 as the divisor. So basically, at this point, when you don't bring down the 8, you have 107 as the, So 107 as the remainder, you just stop there and then don't bring down the 8. You do one division here. So as 96, you're taking as 96 and quotient is 8. And then bring down the 8. And then do a subtraction. So what do you subtract with is the question. So here it was clear that you subtracted the previous quotient, right? In the Bharatiya Ganitam. Here what you do is you subtract with this number, which I will talk about later. You do a subtraction with a special number. So 2 times 7 times 8. So earlier the 7 is here and 8 is a new quotient. So basically the previous quotient and the new quotient. So that's what is done here. So 120 plus 14 is 134 is written as 120 plus 14 times 8. So 960 plus 112 is 1072. So this 1072 is split into 2. So that is the simplification. So basically, earlier what we did is we took a Brihad Haranam. Brihad Haranasya Laghu Haranam Anantaram Vyavakalanam iti kritavantah. Idanim punaha tathaiva kriyate. So you have to take the bigger divisor and again break it down into a smaller division and a subtraction. So Bharati Tirtha Swami method is even simpler. So basically you will not exceed, the divisor will not exceed twice the first number which is here. You found the Varga Kriya here, you found the largest number whose square is fits into this. So twice that number will be the maximum divisor here. The maximum divisor is always 12 in this method. So this is, and basically if you have bigger numbers, this method is a little bit, you have to think about a little bit, you have to keep track of how many digits in the square root will be there and all these things. So I've given a homework in the latest homework number. I think I gave a very large number, so you might run into difficulties. So I'll change the number into a much smaller number so that if you look at this, you can just do the square roots. Okay, so Brihadharanam, Laghuharanam plus Vyavakalanam is what the technique is. So what is this number? Harananantaram kim kriyate iti chet dvandvaha shodhyaha. Shodhyaha nama Vyavakalanam kriyate iti. Atra pashyantu ka kha ga ga iti chatvaraha antaha santi sankhyayaam. तस्य द्वन्द्वः एवम् अस्ति एवं द्विघ्नः आदि च अन्तश्च अनन्तरं मध्ये अपि तथा. So it is twice the extreme numbers plus twice the numbers in the interior. So if you have 4 digits, this is the dvandva. So if there are 5 digits, if there are odd number of digits, so instead of even number of digits, you just take the twice the extreme and then twice the interior numbers. So it will be sum of 2 terms. If there are odd number of digits, like say 5 digits, the middle digit is just squared. It's not twice. It's not squared with twice multiplied by 2. It is just squared. That's all. So twice the extremes and the interior numbers, and then square the middle number. That's all. Tarhi atra pashyantu samankanam sankhyanam dvandvaha. Atra dvandvasya atra navatrimshat iti asti. So if there is 39, you just multiply 2 times 3 times 9, you get 54. So if there are 4 digits, so you multiply 2 times 7 times 6, and then 2 times 3 times 4, you get 108. So if there are 6 digits, you do 5 times 8 times 2, 2 times 9 times 2, 2 times 1 times 3. So this is what you get. So 122 you get. Vishamankanam sankhyanam dvandvaha. So yadi Vishamanka. So Samanka means even numbers. Vishamankanam means odd numbers. The number with odd numbers, number of digits. Vishama, Sama. Vishama means odd, not equal. Sama means equal, so even. Dvandvaha yadi prayaha ankaha santi. So 409 means 4 times 9 times 2 plus 0 square. It's 72. So 2, 6, 7, 3, 4. So 2 times 4 times 2 plus 2 times 6 times 3 plus 7 square. You get 101. So if there are like 7 digits here, so you take the extremes 4, 2, 6, 1, 3, 0 and 9 square. Oh, I think I made a mistake here. It's 7 square I've written. So there is a mistake here. So I have to write either either I have to change this into 7 or change this into 9. Okay, I'll change this into 7. It's easier. So that is the. I'll change, fix a typo in the slide. So that's the dvandva. So what we are subtracting earlier in the slide is the dvandva of. So basically, you leave out the first number. The second number is 7, and third number is 8. The first quotient is 7. Second quotient is 8. So 2 times 7 times 8. You have to subtract. So 112 is what you're subtracting. So this is something which is mentioned in the book on Vedic mathematics by Bharati Tirtha Swamiji. So basically, the divisor is much lesser always now. So that is a new thing which we are seeing. Okay, so I have a homework question, so hopefully you will be able to practice and understand the use of it. Okay, so I'll now go to the next, another point which is there in that book of Vedic mathematics. So, atra pashyantu sankhya sthanani atra dasha ityasya मूल्यमस्ति चत्वारि इति एकस्थानस्य 8 इति अस्ति. तस्य अत्र मूल्यं किं संख्या का इति चेत् दशस्थाने 4 एकस्थाने 8 इति चेत् 8 इति. So this is the just the place value system. This can be represented in another way here. So dashasthane 5 ekasthane rina sankhya 2 iti. So it is in the ones place there is a -2 rina sankhya iti uchyate. So in Bharatiya Ganitam rina sankhya uchyate, it's given but not much. Indian mathematicians have not gone much into detail of negative numbers and also decimals and all these things. But in Vedic mathematics, in the first chapter itself, you will see something called reciprocals, and you will go decimal number system. So it's all very recent advances. Recent means came in the past 2 centuries, or maybe a little more. But by in Bharatiya Ganitam, we never see any decimal numbers being addressed. So this 5 and -2 in the place values. So the value of any place being a negative number is something which Bharati Tirtha Swami he brings it in. So this means 5 times 10 -2. So the ekasthanasya rina sankhya asti. So it's the same number which is actually written in a different way. So this here I am giving a different font for the different color for the number 2 for the negative numbers. So this number is actually not, you cannot call it -52. It is a +5 and a -2. It is a number where we have in the place values some numbers are negative, some numbers are positive. So it's a mishritam ankam. Mishritah ankah atha mishrankah iti uchyate. So this term is given in a book called Indian Mathematics by Dr. Ashok Jhunjhunwala, who was a director of electrical engineering in IIT Madras. So he wrote a book called Indian Mathematics. So in that I think he coined the term mishrankah. I think here also there is a typo, mishrankah iti asti, mishrankah iti bhavitamyam. Mishrankah, ankah mishritam asti, ankah mishritah asti. So this particular kind of methodology is seen in Bharati Tirtha Swami book, and he calls it a Vinculum Method. He even gives it an English name, Vinculum Method. So he puts a bar on top of it, like a parenthesis. It's a Vinculum, he calls it. So this 52 is a mishrankah. So using this method, he also solves some things. But this mishrankah, this kind of imagining a number is not new in Indian system. Atra pashyantu. एकोनविंशतिः इति अङ्कः इति संख्या एका अस्ति एकेन ऊनाविंशतिः तत्र एकेन ऊनाविंशतिः विंशतिः अनन्तरम् ऊना एकम् ऊनम् अस्ति तद् 19 इति अर्थः तत्र एकोनविंशतिः इति इदानीमपि व्यवहारः अस्ति तथैव द्व्यूनचत्वारिंशत् द्वाभ्याम् ऊना चत्वारिंशत् एतस्य 38 इति अर्थः तस्य अर्थः तथैव ऊनाशीतिः अत्र ऊनाशीतिः यदि ऊना इति ऊनम् इति उच्यते एकेन एव इति अर्थः एकेन ऊना अशीतिः अत्र सप्ततिः नव च अत्र पश्यन्तु एतत् सर्वं 38 19 इति समस्तप्रयोगः समासः अत्र व्यस्तप्रयोगः सप्ततिः नव च इत्यपि वक्तुं शक्नुमः अत्र द्वन्द्वसमासः इति प्रायः अत्र समासः नास्ति so this also just I wanted to give you we can write 10 numbers in different ways in the Indian systems so that's in the Vangmayam that's what is there we've seen quite a bit about this in our homeworks and in our Sadratnamala itself so edat tu padona dashavadanam iti chet padena ऊनं दशवादनम् इति वयं जानीमः तत् प्राथमिकस्तरे अपि उच्यते सो पादोन इति अत्र ऊनं दिस् कैण्ड् आफ् मेकिङ्ग् इट् लेस् फ्रम् टार्गेट् number which it's always very common in Indian systems. For example, even in Hindi, I think unatis we say. So basically those kind of numbers are there in all Indian languages. So basically this kind of imagining a number lesser than some closer bigger number is very common in Indian systems. So this kind of thing, so whatever I showed here is not very new. So Bharati Tirtha Swamiji uses this technique to solve some problems. How do we solve? For example, let's Vargamula Kriya atra asti. Atra purvam asit Grihapataha tatra evam asit. Atra you start with this number 956484. So I directly picked this number from the homework. If you've done the homework, you'll really understand this. So you subtract 81, 9, and then here 146 is the, you bring the 6 here. So 146 you divide by 18. So it goes 8 times 144, and if you subtract, you will get a remainder 2, and then you bring the next number. You have 24. Now you have to subtract 8 square. So 8 square is 64. 8 square is 64. So when you subtract 64, you'll get a negative 40. So what we did in the homework was we went back and we said, okay, this should be corrected. We take it as a 7 and then subtract 7. If you say it's a 7, you'll get a bigger remainder here. And then you have a 4 here. You'll subtract 7 square, subtract 49. You'll get a positive number here, right? So, but you can, by using this Mishrankaha, you can go one step, you can just proceed like this. So basically, let's say I proceed 40, negative 40 is what I have. So negative 40 I write as this red, writing in red is, I said this is a negative number. So negative 40 and this let's say 8, I bring it down. So the units place is positive 8, the tens place is 0. I could have made this 0 does not have a negative or positive, right? So I could have made this color black also, but let me keep it as red. So negative 4 is the hundreds place, 0 is tens place, and 8, positive 8 is the units place. Now I have to divide by 98. So what I do is I multiply 98, I have to divide by 2 times 98, which is 196. So 196 times negative 2. I'm going to take the quotient as negative 2. So then I will get one thing which to be subtracted as negative 390. I have to subtract as 196 times negative 2 times 2. Sorry. Okay, I'll come back again. 196 times minus 2 is just minus 392. So this is again a negative number. I'm going to subtract 408. This number is actually what? It's actually 392 because it is 400 minus 400 plus 8, which is minus 392. So that's what is going to happen here, minus 392. So I'm going to subtract minus 392 minus 392, which will make it 0. So minus 392 minus 392, which will become plus 392. So I'll get a 0 as a remainder. And I bring down the 4. And this is minus 2. So minus 2 square is 4. So I get as 2, 8, negative 2, which is 980 minus 2, which is 978, which is the required answer. So basically, I don't have to go back and do the correction. If I am comfortable with doing this Mishrankaha, then we can keep going like this. And at the end, we do the correction. Just convert the Mishrankaha into normal number. So this is another technique which is there in the Vedic mathematics. If you want to continue with this and practice this, it's much easier. I mean, by practice, this becomes, you'll be very comfortable with having negative numbers in the place values and all these things. So this book on Vedic mathematics has a lot of these techniques with Mishranka techniques. So that's where he brings the speed mathematics, all these things. So this is one thing which you can pursue. But I'm not going to go much more deeper into this. This is where I wanted to show two techniques from the Vedic mathematics book, which is different from the Bharatiya Ganita. Okay, so तर्हि पाठसंक्षेपः किं पठितवन्तः अत्र दश सत्रेषु भारतीयगणितपरम्परा. सो प्रथमं तु भारतीयगणितपरम्परा. So there is a question in the previous slide. So cube root is also possible with both these methods. Yes, cube root is also possible with both these methods of Mishrankaha and the previous. So Bharati Swamiji gives cube root techniques also, but I didn't go into detail because I didn't want to. It's actually a proper class. I have to teach that, so this is not beyond the scope of this. I just wanted to show a couple of things. There are a lot of books written in Vedic mathematics, but I think they don't go into details of this cube rooting and all these things, which is they stick with this earlier chapters of the book where the speed mathematics is given. And I have not seen any book going into these kind of details. Okay. तर्हि भारतीयगणितपरम्परा भारतीयगणितपरम्परा का इति दृष्टवन्तः आर्यभट्टः अत्र बहुभिः उच्यते आर्यभट्टः इति. So it's not आर्यभट्टः, it's आर्यभट्टः. So the टकारः एकः एव टकारः अस्ति तत्र. आर्यभट्टः भास्कराचार्यः इति सर्वं ततः आरभ्य. अनन्तरं केरलीयगणितपरम्परा starting around 13th century or 14th century, 13th century prior, probably. Kerala Ganita Parampara, Madhavatah. So starting from Madhava until basically Shankaravarma. So Shankaravarma was the last mathematician on paper in the Kerala Ganita Parampara. So after that we studied Bharati Ganita Granthanam Parichayaha. So we also gave we also learned about some of the names of the books written by Bharatiya Indian mathematicians. Kechana Grantaha api tatra ullikitaha. Tani janantu atra Grantanam namani janantu tadeva asmakam mukhya vishayah. So we should know at least what are the books written by Indian mathematicians. Every time it's only Vedic mathematics or Aryabhatta, Lilavati, Aryabhatiyam and all these things. There are much more out there. So we should know the names of the books. So please get yourself, at least what I want from this class is you at least know the names. Mahaviracharyasya Ganita Sarasangraha, Anantara Pati Ganitam, Sridharacharyasya. It's sarvam janantu namani. Tad mukhya vishayah. Sankhya-sthanani, Brihat-Sankhyanam Namani cha. So this again is one thing which is, I hope you got to know on this class. So the names of this big numbers. So that is one more objective of this class. Another Parikarma Ashtakam. Sadratnamala Uktam. Sadratnamalayaha Malayam Uktaha Asti Vishayaha Parikarma Ashtakam. So we spent most of the time, at least 80% of the time in the class, going through this Parikarma Ashtakam. Sankalanam, Vyavakalanam, Gunanam, Haranam, Vargaha, Vargamulam, Ghanaha, Ghanamulam cha iti Parikarma Ashtakam iti. Anantaram Bharati Ganita Grantebhyaha Tikabhyaha cha Parikarmashtaka Vivaranani Kvachit. So in the homeworks I gave all this what the Tika Grantha also says. So basically these are books. There are a lot of books written. On the books there is a lot of commentaries also written. So basically I took some commentaries from Lilavati's commentary, Patiganitam Tataha comment, Tika, and from in the homework you have Sridharacharyasya Patiganitasya Taha Kinchit Sridharacharyasya Kaha Grantaha Tasya Tika Grantha I forgot. So basically so all these things, there are also commentaries written. So let's at least know the names of this, and there is also Tikas written. So those things we should know a bit. And then Katapayadi Sankhyabihi Sankhya Nirdesha. So we learned how we can represent a number using Katapayadi Sankhya. So Katapayadi, so writing a number in the verse form. And Bhuta Sankhya Prayoga Tathaiva Asti. So Katapayadi Sankhya, Bhuta Sankhya, different ways of writing numbers in terms of using verses. Shulba Sutreshu Vikarani Atra Vikarani Nama square root of 2. So, and we also looked at rational approximation of irrationals, how Shulba Sutras are quite old texts, around 300 BC or like maybe 500 BC. So those, how did discuss approximate square root of 2. Vaidika Ganite Vargamula Kriya. So today we talked about this. Vaidika Ganite Vargamula Kriya, I think. Another Panchanga Paribhasha. So Panchangam, what in Panchangam, Panchangani Kani, iti, Tithivara Nakshatra Yoga Karanam, iti, Tasya Vivaranani Patitantaha. Another Kalamanadi Paribhasha. So these are units, metric units. Right now, I think the world is going towards more metric units. I think in India, we have more metric, even in the shops you buy things in kilograms and all these things. I think even 30 years back, they were in different units, in different units. So basically, in America, it's still in ounces and pounds, and like they don't want to adopt the metric system. So basically, I also heard that Europe, from the European Union, the British, the UK has moved out of the British European Union, so they want to go back to this non-metric systems like ounces and all these things. So, but mostly in India now we are moving to all these metric systems. So, so Kalamanadi Paribhasha, right now it's not much of use. It's all just archaic now. Padita Vishayanam Abhyasaha. So, Etat Mukhya Vishaya Hasti. So, we had fourth homeworks already out. So, based on only if you practice all these things, you will know. Otherwise, you will keep on doing whatever is being taught in schools and all this. So these are new. If you want to learn new techniques, you have to practice. Mathematics comes only by practice. So that's why I didn't want to give any exam for this course. Only homeworks. Your certificates will be based on the homeworks. And from Sanskrita Vakyeshu Ganita Vishayanam Prayoga. So Purvamapi Yuktavan Atra Gunanam Katham Likhamaha Katham Vadamaha. Anantram Kalamanadi Paribhashayam Api Tatha Asti. So there's a homework book question on this. So how do we represent an equation in words in Sanskritam? So Sanskritam, you know, has Vibhakti, Vachanam, also Lingam. So these things we have to be very careful. We can't write something whatever we want. So we have to, the sentence structure should be following the grammar rules. So that is one thing which it needs some training. It's a skill to just write mathematics using Sanskritam. So all these books are written based on that, how they codified in verse forms. So this is Pata Sankshepa. So basically we have learned so much in this 10 lectures. Hopefully you got some of these and it was useful. Astu tarhi agre kim. So you learned this. What do we do going forward? Just because this will not stay in your mind if you don't practice it or don't take it forward. So the whole point is, as I said previously also, I am like a tour guide, that's all. So I'll just tell you, okay, these are the things there. So you go and explore. So Prathamam, Samskrita Pathanam. Mukhya Vishaya, Adharabhuta Vishaya asti. Samskrita Pathanam, if you want to continue on this, you have to learn Sanskritam. So earlier, I think there are so many registrants, around 390 or like around 400, close to 400 registrants. And now the class has around 20 people. So the first class, by just making this statement that I will teach this in Sanskritam, I drove away a lot of people. So that is one thing which a lot of people expect. They rely on translations to read these books. Yadi tatha kurmaha agre gantum na shaknumaha sarvada atra अनुवादमेव पठामः अत्र टीकामेव पठामः स्वभाषया एव पठामः इति सर्वं भवति. So Sanskrit Pathanam is very, very important. You have to continue or you have to start the Sanskrit. I think most of you here are studying Sanskrit, otherwise you will not stay this long. But Sanskrit Pathanam is very, very important. So, and where do we go to learn the Sanskritam? We are the right place. So we are in vyoma-samskrta-pathasala. So the main goal for them is to propagate Sanskritam, teach Sanskritam. So they have courses at various levels, starting from the basic level to very advanced level. So you find out where you fit in. So if you can also talk to them, they will tell you where you fit in, and then start from there. And you have to spend effort to learn Sanskritam. This doesn't come in one day. You have to spend time. You have to give your you have to be regular on this. So only then you will study Sanskritam and your level will advance. Anantaram, Ganita Granthanam Satikam Mulani Sanskritena Eva Pataniyani. Atra Ganita Granthanam Parichayaha Aham Uktavaneva. Parichayam Aham Karitavaneva. Tatra, so you have to take those books and then read that in Sanskritam. So if you think that, okay, I'm not able to understand, bring your Sanskrit knowledge up to that level. So it takes just 2 to 3 years of very regular studying and dedicated studying to bring yourself up to that level. These books are not written in very advanced Sanskritam like Kalidasa or somebody. Like it is very simple, but you have to bring yourself to that level. Satikam ityukte tika sahitam iti artha. Granthanam tika sahitam mulani samskriteneva pathaniyani. So you have to read those books in Sanskritam. Only then you will go forward. Sanskritena Ganita Shastrasya Pathanam Mukhya Vishaya. I hope I'm sure there are quite a few mathematics teachers in this class. I hope you can teach this to others. If you do not teach, you will not. It will not stay with you. So, and it's also something you have to pay back. So, for example, vyoma-samskrta-pathasala, even though they ask you for some donation, they are not charging you any fees. The only fees you can give to them is teach them to others. So basically, and also the great service, your learning does not, learning is not complete until you teach something to others. That's what my guru says. Saraswati, Saraswati Namastubhyam we say, right? So Saraswati, she feels suffocated if you just keep the knowledge with yourself, within yourself. You have to just share the knowledge. Only then this will stay with you, and also you will also advance. If you don't teach, you will still have doubts. If you teach, it will be very clear to you, the concepts. So that's one thing. I actually I taught this course because I wanted to know this, know what is there in this text. So I gained what I wanted. उपयोगि पुस्तकम् अत्र भारतीय गणितपरम्परा इति सद्यः एव प्रकाशितं संस्कृतसंवर्धनप्रतिष्ठानम् इति अत्र. So there is a Sanskrit promotional foundation which is started very recently, and they have publishing books. So Bharatiya Ganita Parampara iti idanim. So this was published 2 months back or 2-3 months back. So this book is very useful. So you can buy this book and then it will be very useful for you to start this journey. Anantaram, amudrita gantraha mudritaha bhavantu. So this is a long-term goal for us, for all of us. We should all take it up. So there are, as I in the first cluster I mentioned, there are so many books which are out of print. So we should try our best to bring those to print. How? We don't know. So we have to go and talk to people. There are very few scholars who are trying to do it. Professor Ram Subramaniam in IIT Bombay, Professor M.D. Srinivas in Chennai Policy Studies and all these things. So Center for Policy Studies in Chennai. So there are people who are doing research, and if more people come into this field, it will become easier for people. So if only 4 people are studying the whole world, then this will go very slow. So if, like, let's say, hundreds of people are studying this, things will go forward. Okay, so you can go to the Sanskrit Promotion Foundation. The book, where is the book available is the question. You can go to, you can Google for Sanskrit Promotional Foundation, and you will see this book in their bookstore. Google for Sanskrit Promotional Foundation. Okay. इदानीं मम कृते किञ्चित् कृतज्ञता समर्पणं. So I have to acknowledge a lot of people here and for doing this course. So basically, प्रथमं ईश्वराज्ञा. So God's grace, अपि च गुरुकृपा च. So basically, यथा सद्रत्नमालायां शङ्करवर्मा अपि वदति, श्रीगुरुचरणाम्बुज स्मरणं किं किं न साधयति इति. अत्र श्रीगुरुचरणाम्बुरः स्मरणं किं किं न साधयति इति. अत्र गुरु अनुग्रहं विना किमपि न सिद्ध्यति. तथा ममापि गुरुकृपा एव एवं if I am doing something, it's only because of Guru Kripa. And whatever mistakes I'm doing, it's all mine. But whatever I've done till now, whatever I've taught, it's all because of Guru Kripa. Another vyoma-samskrta-pathasala sanchalakaha. So a lot of people who are going through this. So for example, Bharadwaj, who is here, he has helped me a lot. Venkat sir, Vishnath sir, when they came here 4 years back in 2018, I think, 2017, they looked at, I had this book which was lying in my book library for quite some time, Sadratnamala. He said, why don't you teach this as a course? So I didn't know anything about it. So it took me 4 years to even teach the first 2 chapters of this course. So he was the first one who told me to, why don't you just pick it up and start teaching this. So I thank them, Dr. Soumya Krishnapur, who's the course coordinator for all the courses. So I thank her also. She only gave me a lot of this, for example, template and all. She helped me in this. And also Preranadayakaha Anandavaryaha. So Anand Vishnath ji, who taught a course completely in Sanskritam, Leelavati courses. The courses videos are available in the vyoma-samskrta-pathasala. So he told me, go for just by learning Leelavati is not enough. You pick up a book and start teaching. So, and then he kept pushing me towards teaching this Sadratnamala. So I thank him also. Purvam maam bharatiya ganitam praveshitavantah patitavantah cha acharyah. So I was lucky to come under, learn under a little bit under Professor M.D. Srinivas, Professor Ram Subramaniam and all these things. Like 20 years back when they taught me a little bit of all these things. So the seed was sown then. So I still am continuing. So I'm glad and happy, and I want to thank them also. Asyam kakshayam jignasoha grahapatan samarpitavantah cha. So people like you who come and learn and submit the homeworks. So I'm very happy that there are people who are interested in this knowledge, and you are also doing the homework sincerely. So I thank all of you also who took interest. If there are no students, there is no teaching, right? So basically, let's say I want to teach and nobody comes forward and learn. So there's nothing I can do about it. So I'm glad that that some of you are also interested in this, and hopefully you take it forward. Okay, there's a question about please suggest some good resources to teach Vedic mathematics to kids. there are so many books in the market. Vedic mathematics is some thing. I mean, I think Vedic mathematics is really being talked too much about. I mean, there are books in the there are so many books in the market. You can just pick any book and start teaching. It is something like, okay, it's a fashion, right? Just I learn Vedic mathematics and all these things. Okay, there is another question. Will you be teaching any other related courses? I want to, but right now I don't have any more knowledge, so I have to equip myself to start teaching. So sometime down the lane, maybe two years later, I wanted to teach Bijaganitam, which is algebra in Indian mathematics. So right now, whatever we study is arithmetic, right? The Patigantam, all this addition, subtraction with respect to numbers and all these things, operations. There's also a good amount of work in algebra, for example, solving equations, linear equations, indeterminate equations, all these things. Okay, so तर्हि तदेव समापयामि. भरद्वाजः अत्र अस्ति. Bharadwaj, you can take over. धन्यवादः.
नमः सर्वेभ्यः. So entry into Indian mathematics, right? So right from the decimal system in the arithmetic to trigonometry, Indian mathematicians such as Aryabhatta, Varahamihira, Bhaskara, many others have given new heights to scientific discoveries in ancient India. But when it comes to lesser known works or even commentaries or major scriptures, fewer resources are available to the new generation and to scholars who wish to study, say, Shulva Sutra of the 8th century BC or the or even Sadratnamala of the 19th century. So I think we at Vyoma take this moment to thank Dr. Chandrasekharan sir. Thank you, sir, for taking this course on vyoma-samskrta-pathasala and helping us reach, at least partially reach, a few people who want to take these kind of courses. So let me just quickly go to the course analytics part of this one. So the number of registered learners as of today is 378. There have been 10 sessions, including today. So 9 lessons. So today's lesson will be included in this. So total number of video hours that are available are 9 hours and 54 minutes. The average number of live attendees that have come on the course is 40. I'm sure sir has already told you that there will be no course and assessment for this particular course. Whatever the homework that sir has already given us, that will be assessed, and then based on that, your certificates will be provided. Please note that certificates are issued to only those who have scored more than 60%. The cumulative, this one should be more than 60%, only then you will be receiving the certificates. Hopefully by by 15th of July, we will be able to provide you with the certificates. So next, Chandrasekharan sir has already told you much about Vyoma. You already know a lot about Vyoma. So even then, you take this chance to ask for a humble seva from your end. So just quickly, just going through the seva metrics that we have. We have 18 self-learning multimedia products, 290 plus free courses that are available right now on the portal, 16 plus free mobile apps, both on Android and on iOS platforms. more than 6,500 video and audio content that is available exclusively on the sanskritfromhome.org portal, and more than 47,000 committed learners who are there, who are supporting us. And all of this has been possible only through a generous support from learners such as yourself. Chandrasekharan sir has already told you how you can do more. So how you can be more, be a part of this journey. So like he said, teaching is something that will always help you learn more. So apart from teaching, you should also practice. Like he said, practice it at least for 30 minutes. That I will spend 30 minutes of time of the whole day that I have. I will spend 30 minutes to practice what I have learned. And then I will also share this knowledge with at least 3 people. That helps you learn more and also to spread your knowledge. The other thing that you can do help Vyoma is through referring the Vyoma courses to others. Vyoma courses, as you know, already available for free. We also have products available for every persona of age groups that we do. So it is one person every day. Talk to them in Sanskrit, talk to them about Sanskrit, spread the word, and there is a lot you can do. All of this can be done. If you want to donate in kind or volunteer with us, you can always do that. For Indians, we have the ATG tax benefit available. You can go on to our web portal, sanskritfromhome.org, click on the donate button, and then make your donation. How much ever this one, every drop counts. And of course, you can write a check or send us an online transfer. All the details are given here. For those who are in the US and you want to donate, there are, you have the, you can log on to our website, vyomausa.org. We have, and you can donate through there. For those in the US, you get the 501c3 tax benefit also. Alternatively, you have the PayPal app. Through the PayPal app, you can also donate. So for any issues, for any questions, you're always free to talk to us. We are available on all the social media handles. We're available on Skype. We are available on WhatsApp. We are available on emails. You can look at all of our offerings on our website, sanskritfromhome.org, digitalsanskritguru.com, which is our product website. And of course, our corporate website is the vyomalabs.in. We iterate, again, this is purely optional, and those who want to donate can donate. Thank you once again.